Hi guys, welcome back to Calc5 videos. In this video, we're going to be talking about question 4 from 2018 free response portion. In this problem, we're given this table showing the years and the height of the tree over this specific time interval between year 2 and year 10. And also we know that this h function is twice differentiable function. Alright, in the first problem it says use the data in the table to estimate h prime 6. So the way we're going to estimate the value of h prime 6 is going to be using the closest time around t equals 6 and apply the average rate of change. Alright, so part A, h prime 6 is going to be equal to approximately h of 7 minus h of 5. So these are the closest time around 6 divided by 7 minus 5. So we know that h of 7 is, as you can see, 11 minus h of 5 is 6 divided by 2. So 11 minus 6 is 5 over 2, which is 2.5. Okay, so that means the question is also asked us to interpret the meaning of h prime 6. So the meaning of that is h prime 6 is the rate of change in the height of the tree in meters per year at time t equals 6 years. Alright? Okay, let's move on to part B. In part B it says explain why there must be at least one time t over this time interval 2 less than t less than 10 such that h prime t is actually equal to 2. So this is the perfect example of mean value theorem. So in order for us to apply the mean value theorem, we need to know that if this h is continuous over this time interval. In the original problem, it says that h of t is twice differentiable. If a function is differentiable, that also implies that it is also continuous. So we can apply the mean value theorem. So let's remember what is mean value theorem. So the mean value theorem over this specific time interval, there's going to be at least one time t that is going to satisfy both average rate of change and the instantaneous rate of change. So the average rate of change, so if we apply the mean value theorem for the t equals 3 years and t equals 5 years, the average rate of change for them will be h of 5 minus h of 3 divided by 5 minus 3, and the instantaneous rate of change will be h prime t. So the h of 5 from the table, it's going to be equal to 6 minus h of 3 is 2 divided by 5 minus 3 is 2 equals h prime t. So 6 minus 2 is 4 divided by 2 is 2. So from here, h prime t is going to be equal to 2. So the meaning of that, by the mean value theorem, there exists a value of c, or value of t, on this time interval between 3x and 5, such that h prime t is equal to 2. We'll just prove that. Alright, let's move on to part C. In part C it says use a trapezoidal sum with the 4 subintervals indicated by the data in the table to approximate the average height of the tree. Okay, so it says find the average height of the tree. So let's remember finding the average value of any function. So it's going to be equal to 1 over b minus a times from integral from a to b f of x dx. So now we're going to apply this formula and generalize that to the h function. So the part C, that's going to be equal to, the time interval is from 2 to 10, so it's going to be 1 over 10 minus 2 times integral 2 to 10 h of t dt is going to be equal to approximately, if we apply the trapezoidal sum, so that's going to be equal to 1 over 8 times parentheses 1 times 2 plus 1.5 divided by 2 plus 2 times 6 plus 2 divided by 2 plus 2 times 6 plus 11 divided by 2 and plus 3 times 15 plus 11 divided by 2. So we just applied the area formula for trapezoid. So now the last thing that we need to do is to simplify this expression. So 1 over 8, that's going to be equal 1 over 8 times 1.75 plus 8 plus 17 plus 39, and this is going to be equal to 65.75. Sorry, so 65.75 divided by 8, and this is going to be equal to 263 divided by 32. So basically, my reasoning is the average height of the tree over this time interval from 2 to 10 is 263 divided by 32 meters. Okay. All right. Let's go on to part D. In part D, it says the height of the tree in meters can also be modeled by the function g, as you can see here. This is the g function. Okay. So, it says where x is the diameter of the base of the tree in meters. So when the tree is 60 meters tall, so when this is equal to 50 meters, I'm sorry, I said 60. So when this is equal to 50 meters tall, the diameter of the base of the tree is increasing at a rate of 0.03. So basically, we're actually given the d diameter over dt. We're given that, which is equal to 0.03. Okay. So now we're being asked to figure out the rate of the change of the height of the tree with respect to time. So we need to figure out dg of x over dt. Okay. But first, we need to figure out the value of x, because we need that when we take the implicit differentiation. Okay. But first, we need to figure out the x value. So I'm going to solve this equation. 100x divided by 1 plus x is equal to 50. If I do a cross multiplication, I'm going to get 100x equals 50 plus 50x. If I combine the like term on the left hand side, we're going to get 50x equals 50. And if I divide this side by 50, we get x equals 1. So I'm going to use this, and I'm going to use also this rate of change. All right. So dg of x over dt, that's going to be equal to, if I apply the quotient rule, 100 times 1 plus x minus 100x divided by 1 plus x all squared times dx over dt, since we're taking the derivative with respect to time. Alright, so we know the x value, so 100 times 1 plus 1 is 2, minus 1 times 2 divided by, I'm sorry, this is going to be 1. So it's going to be 100 times 1 divided by 1 plus 1 is 2, 2 squared is 4, and times dx over dt, which is 0.03. So this simplifies to 0.75. That means, according to the model, the rate of change in the height of the tree with respect to time, when the tree is 50 meters tall, is 3 over 4 meters per year. That's the meaning of this expression. Alright, thanks so much for watching this video. In this video, we've talked about this problem. Thanks so much for watching. Don't forget to subscribe, like, and share, and comment. See you in the next video. Bye-bye.